The track committee has run it to students, primary and higher education students, and they love it. And we have also run it through our libraries. They also have given positive feedback. And more important, more than the users, it is the scientists at Indian Institute of Science and the other people at the IIITB are very, very excited about it. They have endorsed it, and they have put it down in writing that they have never seen such a powerful device at such affordable cost. So if you saw the video properly, it has something called compact intelligence and infinite possibilities. That's what we are trying to do with this. So we've had multiple iterations. We've had the right people endorsing it, testing it, piloting it, and across, including a couple of startups also have seen this, and they also like what they have. So everything is documented. It is nothing that it is at the whims and fancies of the government or the minister or the chairman. We have devised this. It's gone through thorough technology evaluation. The evaluators have ensured they have put everything on paper. We have tested it ruggedly across different environments, including temperatures also. So yeah, it's a pretty robust hardware that we are going to launch tomorrow. And like you are quite aware that QNX does not own any factory as of now or any assembly line. The idea is to get it to engage with entire Q journey has been with startups. We make affordable hardware, especially AI-enabled hardware on scale, so that we can ensure grassroots computing. That is very important for us. So we have partnered with one semiconductor company, and we have partnered with a semiconductor design, chip design company, as well as another. So we will reveal the names probably in a couple of days after the launch. Right now, what is happening? Let's say when I want to deliver, like I run 6,000 libraries. QNX has bagged a contract of 15,000 computers and procuring for a cost of what, 45 crores, 75 crores, and they are helping me procure it for the Department of RDPR. Now, my question was, do I really need such powerful machines in my library? The demography that is going to my libraries are students, people who are interested in writing competitive exams, elderly people who are looking at digital inclusion, but the same 75 crores, if I was able to pick up something affordable computing, AI-enabled affordable computing, I would be able to deliver to more number of people. Our students, even engineers. How many engineering students really have computable laptops or computable hardware? Very few. So like I was reading the statistics, only 45% in the entire country. And I know the private schools are just there. So it's just not about student education is a part of it, but how do I disrupt computing itself through engineers, for small startups, for small businesses, for even households. So how do I ensure that I disrupt that entire ecosystem is what we are trying to see. It's going to be a very honest and earnest effort at doing that. With respect to that query, they can do that also. Right now there is nothing available like that. So we are looking at step by step, because this is something that no government has ever done, or even the private sectors, nobody has done it. So we'll see how it goes.
Trained on English. The syllabus is trained in both. It has been trained on the DSCRT syllabus. So Karnataka's own syllabus for 8th, 9th and 10th. The models have been trained on these syllabus itself. Right now it's working with English, but we look that in the future we can expand it and make it work with Kannada as well. So throughout the whole development, we've worked with, as sir was saying, with industry, with semiconductor manufacturers, with startups, and with people from academia and researchers who are working with RISC-V, who are working with various microsystems, and it could be ARM, it could be x86 Intel. With their feedback, with their input, we have developed both the hardware and software part of it. So even the AI training has been done with industry experts, academic experts for training the model for deployment.
It's given Simputer, if you remember. Simple computer by Indian Institute of Science. That's what I said. We missed that revolution. If we had planned better, made it more affordable, or even trialed it out within the government ecosystem, who also happens to be the biggest consumers, then maybe it could have taken off, like you rightly said. So, like I said, the success of Kyo will also depend on how well we have our blueprint and how well it will perform technically. And now with B2G ಅಷ್ಟೇ ಮಾಡ್ತಾ ಇಲ್ಲ, we are also doing B2C. In fact, our first 500 devices that are being sold are B2C, not B2G. So only based after the due diligence done technically, we had a 8-member technical advisory committee, people from Indian Institute of Science, people from semiconductor industry, triple IT, all of them have come, seen the device, suggested to us what improvements can be done. So ಸಾಕಷ್ಟು ಐಟ್ರೇಷನ್ಗಳಾಗಿದೆ. ಸುಮಾರು ನನ್ನ ಪ್ರಕಾರ ಬರೀ ಹಾರ್ಡ್ವೇರಿಗೆ 8 ಐಟ್ರೇಷನ್ ಮೇಲೆ ಆಗಿರ್ಬೋದು ಅಂತ, 8 ಐಟ್ರೇಷನ್ ಮೇಲೆ ಆಗಿದೆ. ರಿಯಾಕ್ಷನ್ ಟೈಮ್ನ ಕಮ್ಮಿ ಮಾಡಿದ್ದೀವಿ. ನಾವು ಫಸ್ಟ್ ಪ್ರಾರಂಭ ಮಾಡಿದಾಗ ಏನೇ ಕ್ವೇರಿ ಕಳಿಸಿದ್ರು ನಮಗೆ 1-1.5 ನಿಮಿಷ ಆಯಿತು. ಇವಾಗ ಇಟ್ಸ್ ಟೇಕಿಂಗ್ ಲೆಸ್ ದೆನ್ 5 seconds. So sorry sir, less than 2 seconds. So this is how we have devised the product. And of course we will have to be more professional, like you said. We will have to run this like a proper product, and we have to run Qionix like a proper corporation.
We looked at all architectures which are available, right? We looked at the deployment of about 20,000 learning devices across various platforms. It could be an Intel-based Microsoft system, it could be an Apple-based system, it could be an Android-based ARM system. So we looked at the deployment of about 20,000 such instances, and one consistent factor which we saw was that the planned obsolescence which is being used turns out to be a very big limiting factor across the lifetime of a product. This was the main reason for us to go towards an open source architecture. So it wasn't that we ad hoc chose it. We chose it because it gives the longest lifetime for a product. We saw that Ubuntu, when it is loaded onto even x86 system, it is useful for about 6 to 8 to 10 years. Whereas if you use proprietary software on these things, obsolescence means that within 3 years, 4 years, you're struggling to keep the device up. So yes, there are various areas in which we could have gone, like for me to go risk, but there was a thought process behind why we said risk, because it's open source. We could have put Android on top of it, but we went with Ubuntu for a reason. So there have been plenty of learnings across about 20,000 devices deployed across various situations. We've taken learnings from
hardware itself. Trust me, you will be blown away that we are able to do something that the private sector has not been able to do. And anyway, tomorrow we'll post the inauguration. We'll be having another major announcement to meet, and I'm hoping to see you there. However, I will answer this question. बहुत ಸಂಕ್ರಾಂತಿಗೆ ಪಾಪ ಯಾರೋ ಸ್ಟಾರ್ಟಪ್ ಯಾರೋ ನಮ್ಮ ಸ್ನೇಹಿತರು ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಿದ್ರು, ಸರ್ ಹಿಂಗೆ ಯಾವುದೋ ಸೆಮಿಕಂಡಕ್ಟರ್ ಕಂಪನಿ ಇದೆ ನೋಡಿ ಅಂತ. ಇಂಟ್ರಡಕ್ಷನ್ನೇ ತಪ್ಪಾಯಿತು ಪಾಪ ಅವರಿಗೆ. ಅವ್ರದ್ದು ಮೂಲ ಬಿಸ್ನೆಸ್ ಬಿಟ್ಬಿಟ್ಟು ಇದೇ ಮಾಡೋ ಸರ್ ಕಚ್ಬಿಟ್ಟೆ ಅವರಿಗೆ. ಸೊ ಇಟ್ಸ್ ಟೇಕನ್ ಎಸ್ ಇಯರ್. ಆಮೇಲೆ ನಾನು ಹೇಳ್ದಂಗೆ ಹಾರ್ಡ್ವೇರ್ ಇರ್ಬೋದು, ಫಸ್ಟ್ ಬಲ್ಕಿ ಇತ್ತು, ಅದನ್ನು ಸ್ಲೀಕ್ ಮಾಡಿಬಿಟ್ಟು ಮತ್ತು ಸಾಫ್ಟ್ವೇರ್ ಇವ್ರು ಹೇಳ್ದಂಗೆ 20,000 ಬೇರೆ ಬೇರೆ ಡಿವೈಸಸ್ಗಳು, ಯೂಸ್ ಕೇಸ್ಗಳು ನೋಡಿಬಿಟ್ಟು ನಾವು ಮಾಡಿರೋದು. ಸೊ ಇಟ್ಸ್ ಟೇಕನ್ ಅಸ್ ಅ ಇಯರ್, ಆ್ಯಂಡ್ ದ ಇಂಟೆನ್ಷನ್ ಈಸ್ ಟು ಎನ್ಶೋರ್ ದ್ಯಾಟ್ ವಿ ಅಡಾಪ್ಟ್ ಆಲ್ಸೋ ಕ್ವಿಕ್ಲಿ. ಇದು ಬರೀ ಫ್ಲ್ಯಾಶ್ ಇನ್ ದ ಪ್ಯಾನ್ ಆಗಲ್ಲ, ಇದು ಒಂದೇ ಸರಿ ಮಾಡಿಬಿಟ್ಟು ಬಿಡೋದಲ್ಲ. ಹೌ ಕ್ಯಾನ್ ಐ ಸಸ್ಟೈನ್ ಫಾರ್ ದ ನೆಕ್ಸ್ಟ್, ನಾವು ಹೇಳಿದಾಗೆ ಡೀಪ್ ಟೆಕ್ ಡೆಕೇಡ್ ಅಂತ ನಾವು ಡಾಕ್ಟರ್ ಮಂಜುಳಾ ಅವ್ರ ಭಾಷಣ ಕೇಳಿದರೆ ಡೀಪ್ ಟೆಕ್ ಡೆಕೇಡ್ ಅಂತ ನಾವು ಮಾಡಿದ್ವಿ. ಸೊ ಮುಂದಿನ 10 ವರ್ಷ ಯಾವ ರೀತಿ ಇದನ್ನು ನಾವು ವಿತ್ ಎಮರ್ಜಿಂಗ್ ಟೆಕ್ನಾಲಜೀಸು ಮತ್ತು ಎಮರ್ಜಿಂಗ್ ಟ್ರೆಂಡ್ಸ್ ಜೊತೆ ನೋಡ್ಕೊಂಡು ನಾವು ಕೂಡ ಬದಲಾವಣೆ ಆಗಿಬಿಟ್ಟು ಅದರಲ್ಲಿ ಆ ಹಾರ್ಡ್ವೇರ್ನಲ್ಲಿ ಹಾಕ್ತಾ ಇದ್ದರೆ ದೆನ್ ವಿಲ್ ಬಿ ಏಬಲ್ ಟು ಗೆಟ್ ಕಂಪ್ಯೂಟಿಂಗ್ ಅಕ್ರಾಸ್ ಡೆಮೋಗ್ರಫೀಸ್, ಅಕ್ರಾಸ್ ರೀಜನಲ್ ಡಿಸ್ಪ್ಯಾರಿಟೀಸ್. ಸೊ ಒಂದು ವರ್ಷ ಆಗಿದೆ, ಆ್ಯಂಡ್ ದ ಐಡಿಯಾ ಇಸ್ ಟು ಹ್ಯಾವ್ ಅ ಬ್ಲೂ ಪ್ರಿಂಟ್ ಫಾರ್ ದ ನೆಕ್ಸ್ಟ್ ಡೆಕೇಡ್. In multiple devices, it can make any device smarter, faster, and AI enabled. ಸೊ ನಿಮ್ಮ ವಾಟರ್ ಮೀಟರ್ನ ನೀವು ಎ ಐ ಎನೇಬಲ್ಡ್ ಮಾಡ್ಬೋದು ಇದರಿಂದ. ಸೊ ಯೂಸ್ ಕೇಸಸ್ ವಿ ವಿಲ್ ಗೋ ಲೇಟರ್. ಫಸ್ಟ್ ಸದ್ಯಕ್ಕೆ ಹೌ ಕ್ಯಾನ್ ಐ ಟೇಕ್ ಕಂಪ್ಯೂಟಿಂಗ್ to the grassroots? How can I make computing affordable? These are the only two things I'm concentrating on. ಆಮೇಲೆ ಅವರು ಯಾರು ಸ್ಟಾರ್ಟಪ್
ಸೋರ್ಸಲ್ಲಿ ಎಲ್ಲ ಇರೋದ್ರಿಂದ ಪೇಟೆಂಟ್ ಅಂತ ಇದರಲ್ಲಿ ಬರೋದಿಲ್ಲ. ಇಟ್ ಈಸ್ ಆಲ್ ಓಪನ್ ಸೋರ್ಸ್. ಸೊ ಉಬಂಟು as a software is open source. RISC-V was developed by Berkeley, which they published as open source. All the tools which we are applying on it are all open source. So ಇದರಲ್ಲಿ ಪೇಟೆಂಟ್ ಅಂತ ಬರೋದಿಲ್ಲ. ಬಟ್ ತಾವು ಕೇಳಿದ ಪ್ರಶ್ನೆಗೆ AI ಚಾಟ್ ಬಾಟ್ನ ನಾವೇನು ಮಾಡಿದ್ದೀವಿ ಬುದ್ಧ ಅನ್ನೋದನ್ನು. See, that is a very first case where an LLM has been applied onto an edge device. ಇದ್ರ ಬಗ್ಗೆ ನಾವು ಕೆಲವೊಂದು ಪೇಪರ್ಗಳನ್ನೆಲ್ಲ ಪಬ್ಲಿಷ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಯಾರು ನಮ್ಮ ಚಿಪ್ ಮ್ಯಾನುಫ್ಯಾಕ್ಚರರ್ ಇದ್ದಾರೆ ಮತ್ತು ಸಿಸ್ಟಮ್ ಇಂಟಿಗ್ರೇಟರ್ ಇದ್ದಾರೆ ಅವ್ರ ಜೊತೆ ನಾವು ಸೇರಿಕೊಂಡು AI ಸಿಸ್ಟಮ್ ಇಂಟಿಗ್ರೇಟರ್ ಯಾರಿದ್ದಾರೆ ಅವ್ರ ಜೊತೆ ನಾವು ಸೇರಿಕೊಂಡು ಕೆಲವೊಂದು ಪೇಪರ್ನ ಪಬ್ಲಿಷ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಬಟ್ ಚಿಪ್ ಆಗಿರ್ಬೋದು, ಸಾಫ್ಟ್ವೇರ್ ಆಗಿರ್ಬೋದು, ಪ್ರೋಗ್ರಾಮ್ಸ್ ಆಗಿರ್ಬೋದು, ಟೂಲ್ಸ್ ಆಗಿರ್ಬೋದು ಎಲ್ಲ ಕೂಡ ಓಪನ್ ಸೋರ್ಸಲ್ಲಿದೆ. ಸೊ ದರ್ ಇಸ್ ನೋ ಪೇಟೆಂಟ್. ಬಟ್ the AI chatbot is something which we are very excited about, very proud about, and something which will be the first of its kind, which we will publish papers about as well.